I want to do a gentle advocate as to why it might be interesting to look at the developing world to actually do some of the developing of the technologies and what some of the advantages might be for that approach. I think we've already talked, or we've really heard a number of people talking today about saying that one of the challenges we have when we do a transition is that we have a locked-in incumbent. And David, picking on David's comment earlier on, is to say, what is the added value of an electric vehicle over a diesel? And so one of the questions that we're going to say is there a space we can look at where we can start to do some of the smart development and the smart thinking so that we can do that learning without having the challenges of dealing with an incumbent. So this slide sort of talks about what are some of the grand challenges facing our civilization over this next century. And on the horizontal axis is basically saying what is the ecological footprint that we have as a humanity. This is based on various countries around the world. Around about 2 hectares per person is what's deemed to be sustainable. Take the total ecological land area divided by the total number of people, it gets about 2. So basically anything to the left of that line is sustainable in terms of environmental issues. Vertical axis is talking about the quality of life issues and using the Human Development Index. Anything above about 0.8 is going to be sustainable in terms of the human issues. So basically the only corner that's really sustainable in the long term is that top right-hand corner there between 0.8 and 1. Okay, that top right-hand corner there. And at the moment, no country inhabits that space. So the interesting challenge is that we need to have two big challenges. The first challenge is to say we need to move the high global footprint people to the left. And that's an area I've been doing quite a lot of work in to say how do we do that. But then the second equally important challenge is to say how do we bring those guys who are in the low human development but low ecological footprint, how do we bring them up? And the main key aspect is to take them on a vertical trajectory, not a diagonal trajectory, which is typical of what happens. So what I'm saying is actually this is an interesting space because we land up in the place that the earlier ones needed to go to anyway. So we're getting to the same outcome, but we have a number of advantages using this route rather than the former route. So it's particularly what I've been looking at over the last year or so is looking particularly at to say why do we want to develop for off-grid communities in the developing world? Key advantage number one is that they have a minimal energy infrastructure there already. So you're not trying to replace something. So you're not doing a substitution with all the difficulties of have substitution. Secondly is we can build up an infrastructure which reflects the current constraints. So for instance, as you all know, copper has gone up by a factor of 7 in price over the last 5 years or so. That is a constraint that we have to live with. But also we have opportunities in terms of things like computational power, computational capability and power electronics have means that we can actually do a lot smarter energy supplies as well. That also needs to be reflected in that. The next aspect is that even small amounts of energy in these areas improves the quality of life. It's not that you're substituting one aspect which already provides you that quality of life. Anything that you do there already improves the quality of life. The next one is a more interesting one, is that in those areas, because you're normally dealing with people who are not exactly affluent, there's real price elasticity. So therefore, you've now got a real driver to actually go for an efficient system, an economically efficient system, because the customers do change their demand depending on price, unlike we do in the developed countries. And the last one is that resilience is absolutely required because we know that they tend to be in areas where the climate is changing, where the social aspects are changing. So you need to be developing a system which can manage those changes. So let's give us a little bit of thinking about to say, okay, given that we want to do there, what's the best approach? And one of the things that we looked at was to say, let's pick up what we said about Malcom was saying earlier, is that different energies provide different services. And let's try and see where that takes us. So one of the interesting aspects that I learned over the last year or so, doing lots of traveling around the different countries, talking to different NGOs, identifying what are the top 4 or 5 requirements that people want when they want to go on grid. Number one is lighting. Everybody would have thought that one is fine. Number two is mobile phones. Universally, people want access to be able to charge their mobile phone. That surprised me. Number three is TV. Number four is computing, used by the same one. And number five is sometimes cooling in hot areas. The shaver in the middle of the space actually represents that in certain communities, having one's hair done is absolutely critical, and wherever there's been any form of electrical energy in, the first shop that's arrived is a mobile phone charging shop. The second one has been a hairdresser's. Okay, I was just amazed. In different countries, the same thing happens. So that represents actually one of the things that people want is to have an opportunity to increase their economic livelihood. So that's a key driver. Something that was perceived as very low value were things like refrigeration, hot water heating, or cooking. Okay. Again, me being naive, when I started, I thought these would be one of the top ones, but no, they're not. They're very low value. And there's reason for that, mainly because they have a lifestyle already which does not require any of these particular aspects. Cooking, for instance, is largely done on either gas stoves or wood. Okay. One of the other interesting things, if you sit back and look at these, you can see that those that have high value tend to be of low energy requirements or low power requirements, where those on the low value ones tend to be high energy and high power requirements. This, I think, starts to articulate what Malcom was saying earlier on, is that different energy requirements and different services lead to different ways of thinking through this. So what we're thinking is, say, okay, if you go into a system, going into a rural community, first thing we want to do is provide lighting, and that you can do for something like 10 watts or so. Mobile phones, the same sort of thing, 10 watts. When you go up to the TVs and fans, then you're looking at something like 250, 300 watts per person. When you're looking at economic activity, you could be up to kilowatts. So what does that do in terms of implying how you build and develop an energy infrastructure? So the first thing that we were looking at is to say that one of the things that we recognize is that in a large number of places, you tend to have a central economic hub where activity happens. That's where your dispensary is, your school is, your economic activity. And then you have remote locations for housing. This is not true for everywhere, but this is largely true in a lot of the places we're looking at. So one of the interesting questions is, how do you get energy from the center to the output, to the outer places? And normally one would think of just running a transmission line. We're actually looking at using batteries as a form of energy store to actually carry energy from one place to the other. You have to look at what is your distribution looks like. If you go to somewhere like Bangladesh, this is not an appropriate model because everything is so condensed and so densified. What you then got to look at is to say, how do you actually join the houses together, but with a very weak transmission line? When you start looking at that then starts to talk to some of the challenges we have in this country to say, how do we make our existing distribution network go further, but and to last longer, although the carrying capacity is now starting to get close to what the capacity that people want to use it in. So the learnings can carry across the two. The second aspect we looked at in saying is, can we actually separate the low power services from the high power services, and how do you make a route so they can move from one to the other? So the first standard option is to say, do we go DC or AC? And we know that a long time ago, Westinghouse won that argument and we went AC, went down that route. However, I think there's now an opportunity to potentially look at DC because the technology is far more robust if you can go from 48 volts from your PV to 48 volts in your battery, and you get 48 volts right down to the distribution system. So, and that means that you've got less maintenance issues, and there's a whole lot of advantages of going down that route there. And that's perfectly appropriate for appliances, even such as TVs. Now you can get TVs that will quite happily run off 48 volts, mobile phone charging and the like. That all works fine. The problem is that if you go down a purely DC route, you then lock yourself in. And you avoid, you have the problem of how do you then go later on when people want the refrigerator or the hot water or the cooking as their lifestyle improves. So one needs to have an AC system as well. The challenge there is you need to have an inverter there sitting there, or one can have a grid ready. And so one of the big challenges for us was to say that one of the big costs that you have is, for instance, in wiring up the home. And you don't want to do it twice, one for the DC system and one for the AC system. So what we've been looking at is how do we subvert a conventional three-prong plug socket where instead of having live, neutral, and earth, we have live, neutral, and DC. And then that allows us to now have one system, and we can actually allow for multiple services. We think there might be some interesting aspects behind that, because we know in those in Africa there tend to be a lot of rolling blackouts. If you have a blackout, you still have the battery system, which enable your low power, high value stuff to continue working. We think there might be some interesting opportunities in the developed world for having that type of separation of functionality. The last one I wanted to have a look at is to say that if you're looking at your high-powered devices, they often give you an opportunity to actually do energy storage as well. Although it's not really energy storage, it's really storage of a service. So we've been looking at aspects of looking at refrigerators, where we could say, how could we run a refrigerator together with a PV system? Now, the really daft thing to do, which a lot of people do, is they take their PV, put it into expensive batteries, then use the energy from the batteries to put it into the refrigerator. What we're looking to saying is, well, actually what people want is a cold place where they can store their food. So what we've been looking at saying is, can we develop a refrigerator technology where we can retrofit existing refrigerators, and we can now do it where we put in some phase change material into the refrigerator, and that can now keep it cold for 12 hours. Now what we do is, instead of having energy storage, we have storage as service. And again, it's appropriate for particular aspects. One side that we can say, okay, how does that translate into the Western world? Well, a lot of people use hot water. Even in the UK at this moment in time, there are over 5 million hot water tanks. The energy storage in that is equivalent to 3 to Norwegs. Okay, so there's a lot of energy that's stored in there. That gives you a potential to provide a massive energy store at very little cost. So we're thinking that by re-looking at the way that one does looks at the service, you can look at alternative ways of not only delivering that service, but adding additional service capabilities such as storage onto the system. So what are my 3 take-home messages? We've got new constraints, okay, and we need to have new approaches. We've got to rethink the way we look at systems. By going to the developing world, we can actually leapfrog old technologies. Just for instance, like M-Pesa in Kenya was a mobile banking service. They developed it there. It's now been retrofitted back into the UK, and as of this month, you can now send money through banking service. So the developing world is great for that. And lastly, is that if you want to do real deep innovation, you have to start from your endpoint and work backwards, okay, and really understand what does the customer really need and develop the energy service for that. Thank you very much.